Hello everyone, and in this video we're going to do a quick introduction to imaginary numbers. So first we need to define what is an imaginary number. An imaginary number, I, is equal to the square root of -1. So I is our imaginary unit. So I is equal to the square root of -1. Now, with square roots, if I take the square root of 4, this equals 2. Whatever this number is, multiplied by itself, this will get the original number in the square root. But we don't have a number that multiplied by itself will get the square root of -1. A negative number times a negative number is a positive number, and a positive times a positive is a positive. So we have no numbers that are gonna get us to the square root of -1. So what do we just call the square root of -1 I? It's just I. So that's if you're gonna take away anything from the video, you need to know I is the square root of -1. So another thing we got to know is the powers of I. So what do I mean by that? We need to know I squared, and some people write I like a little curve like that at the end. You can write it like this as well, it doesn't matter. I like the curve. We know I is the square root of -1, so if we square both sides, we get -1. So let's see here. I equals the square root of -1. If you square both sides, I squared equals -1. And then let's look at I cubed. This equals, well, we know I squared is -1, or sorry, let me take it back a bit. According to our laws of exponents, I cubed can be rewritten as I squared times I to the first, or I. This equals, well, we know I squared is -1, so I'm going to write -1, and then I to the first power is the square root of -1, or just I. So -1 times, this is I, this equals -I, okay? So I cubed is I squared times I squared is a -1. I is the square root of, or I is just I. We don't want to put any square roots of -1. We don't want to put square roots of negative numbers here. We just write them as I. That's why we don't write this as negative square root of -1. You just write it as -I. Now let's look at I to the fourth power. This can be rewritten as I squared times I squared, according to our laws of exponents. I squared is -1, and I squared is -1. 1 times 1 is 1, and we have two negatives here, so it's just 1. It's positive, stays the same. And then let's keep going. Let's just keep going. I to the fifth power can be rewritten as I to the fourth times I. This equals 1 times I, which is I. Now, if we go back to our original thing here. We've ended up in a loop. So I to the fifth equals I. So if I keep going, I to the sixth, well, this equals I to the fourth times I squared. This equals -1, okay? So we're ending up in a loop. So what we need to know is, I'm going to write all these down again. I equals the square root of -1. I squared equals -1. I cubed equals -I, and I to the fourth equals 1. And I to the fifth equals the square root of -1, and it just keeps going. So we need to know that pattern. So if you want, write this down. This is something you're definitely gonna have to know. So let's look at some examples here. Let's just mess around with imaginary numbers. Let's get some example problems, and you're gonna, because there's a lot of stuff with imaginary numbers. So let's just fool around with it a bit. So let's do 3 here. 3i plus 2i. Okay? It is exactly the same as just adding regularly. So 3 plus 2 is obviously 5. So 3 plus 2i, or 3i plus 2i is 5i. Okay? Do not write it as 5 square root of negative 1. Okay? That's not the proper way to write it. So with imaginary numbers, you always want to write it in the form a plus bi. Okay? A is a real number, B is a real number, and what I mean by real number is it doesn't have an I in it. There's no square root of negative 1. It doesn't have an I in it. So A and B are real numbers. You always write it in that form. So 5i, there's no square root of negative 1 involved. Now, let's do 3i times 2i. We need to know how to multiply these. So when we multiply, remember, you need to add the real numbers, and then you need to multiply. You need to multiply the real numbers and then multiply the complex numbers, or imaginary numbers. They can kind of be, the word complex and imaginary can kind of be used interchangeably. Imaginary just means I, and complex numbers are, written in the form a plus bi. So 3 times 2 is 6. I times I is I to the 1 plus 1, which is I squared. From your notes earlier, we know I squared equals negative 1. So this equals 6 times negative 1, which equals negative 6. That's the answer. So these first couple problems should not be too tricky, not be too bad. In fact, I'm just gonna go right away. I'm just gonna leave it at that because that's not too bad. I'm just gonna go away from that. Now, it can get quite a bit trickier. So what if we want to simplify I plus 2i over 5 plus I? Now, there's a thing called the complex conjugate, or just the conjugate. The conjugate of something is, we see this, so let's look at 5 plus I. We see this addition symbol. That's going to turn into subtraction. So the conjugate of this is just this. And if we want to go backwards, that's also the conjugate. So the conjugate of 5 plus I is 5 minus I, and the conjugate of 5 minus I is 5 plus I. It's just taking the symbol and doing the opposite of it. Now, why is that important? Who cares? Well, to simplify 1 plus 2i over 5 plus I, we need to multiply the top and the bottom by 5 minus I. It's your giant 1. Now, 5 minus I over 5 minus I is 1. Multiplying by 1 just changes the way a number looks. We're not changing the value here, because if I did 5 minus I over 5 minus I, that's 1. And I'm multiplying the whole thing by 1. It's not changing the value, we're just rewriting it. Now, you can multiply this out however you want. You can use your FOIL method, your box method. I personally like the box method, so I'm just going to do that. But it's really up to you. So 5 times 5 is 25. Negative I times 5 is negative 5i. And then so here's where it gets tricky. I times I is I squared, but there's a negative there, so we're going to slap it on a negative. We know I squared is -1. A negative and a negative, in this case, is just going to be 1. Now, we multiplied by the conjugate not only to simplify this, but we can also get rid of these. So when we use the box method, we have to add everything up. So this is 25, let's see here, plus 5i minus 5i plus 1. And is there a way to get rid of, I don't know. Is there a way to get rid of that? Oh, well, it's fine. Oh, there we go. 5i minus 5i is, well, 0. And then 25 plus 1 is 26. So we did that to just get rid of the imaginary numbers. We don't need them there. We don't want imaginary numbers in the denominator, actually. We need to get rid of them. So I'm going to multiply the other part. So 1 and 2i. I'm going to write that better. 1 and 2i and 5 minus i. So we have 1 times 5, that's 5. Negative I, and then we have 10i. Let's see here. Did I do this right? Yep. Negative I times 2i is negative 2i squared. So this is 2. Because negative 2i squared is negative 1. So this is negative 2 times negative 1. This equals 2. Add all this up, you're going to get 7 plus 9i. Okay. Now, let's just, I'm just going to get rid of all this here. Let's see here. Just going to get rid of all of what we don't need. Whoops. So the top is converted to 7 plus I believe it was 7 plus 9i, I think. Yes, 7 plus 9i. And the bottom was 26. So this equals 7 plus 9i over 26. And that's your answer. So you always want a real number at the bottom and a complex number on the top. And this is written in our a plus bi form on the top, so that works out. That works out there. So let's do another problem. Actually, you're gonna do one right now. So let's do 8 plus 3i over negative 3 plus i. Okay? I'll give you a second to do that. Now, we have a negative 3 here. This isn't, that negative 3 has nothing to do with the conjugate. The conjugate, we just care about what's like in between the real number and the imaginary number. So there's a plus there. So I'm going to multiply the whole thing by negative 3 minus I. Let's multiply this out. Negative 3, I, negative 3. Negative 3 times negative 3 is 9. Negative 3 times I is, or negative I is 3i. Negative 3 times I is negative 3i. So these cancel, these go away. Just cross out the whole thing, actually. Just get rid of it. Don't want to see it at all. I times I is I squared. Negative I squared is 1. So the bottom is going to be a 10. Now let's multiply the other part. 8, 3i, negative 3, negative I. Negative 3 times 8 is negative 24. Negative 3 times 3i is negative 9i. 8 times negative I is negative 8i. 3i times negative I is negative 3i squared. I squared is negative 1. Negative 1 times negative 3 is 3. Add all this up. We're going to get negative 21 minus 17i. So that's what you should have gotten for that one. So let's see here. Let's find other good ones. Now let's look at absolute value. The absolute value of 8 plus 9i. How do we evaluate that? Well, we need to look at the Pythagorean theorem. Now this is going to sound weird, but this is how you do it. So you're going to do the Pythagorean theorem is a squared plus b squared equals c squared. Okay? Hopefully you know that by now. But you're going to take you're going to take both numbers. You're going to take 8 squared plus, not the I, okay? The I is not included. You're going to take 8 squared plus 9 squared equals c squared. So this is 64 plus 81. This equals, let's see here, 145. 145 equals c squared. Square both sides, or square root both sides, sorry. C equals the square root of 145. And that's what this is equal to. And that is a square root that I don't think can be simplified. So that is how you do absolute values with imaginaries in them. Let's do, okay, so now I want you to do, I'm going to do a little bit smaller numbers. You're going to do the absolute value of 1 plus 3i. Try that one. So we'll do our Pythagorean theorem, 1 squared plus 3 squared equals c squared. We're going to square root both sides. 1 squared is 1, plus 3 squared is 1 plus 9, which is the square root of 10, equals c. So the square root of 10. So yeah, those aren't too bad. Yeah. Now let's do purely just let's take our focus all the way back to the beginning. Okay, all the way back to the beginning. You are going to evaluate, okay, what is I to the 13? We're just gonna evaluate I to I to a number. Okay, I to a number. Well, you want to think about these ones just logically. So what can I break up 13 as? Well, this equals I to the 12 plus 1 power. Okay? And this equals, remember, laws of exponents. I can rewrite that as I to the 12th power plus I to the 1st power. Now, if we take our focus all the way back to the beginning of the video, we know I to the 1 is square root of negative 1, all the way down to I to the 4th, which is 1. Or sorry, this should be a multiplication symbol. So I to the 4th is 1, and after that we're in that loop. So numbers, if this is a multiple of 4, and it is, that's a multiple of 4, we can rewrite this as 1. 1 times I, which is I. So I to the 13th equals I. So you want to rewrite it to where one of your I values here is a multiple of 4. That's a really good way to do it. Because 1 times something is the other thing. So 1 times I is I, so we rewrote I to the 13th as I to a multiple of 4, which is 12, plus 1. So that's how we got our answer. So let's do I to the 51st, okay? This can be rewritten as I to the 48th times I to the 3rd, and I to the 48th, we're in that I to the 4th loop, okay? So let's make a side note. I to the 48th equals I to the 4th, and that equals 1, okay? And then let's see. This equals 1 times I cubed, and it really depends on what your teacher wants here. I cubed and negative I are, I wouldn't really say there's any like more simpler version. So it really depends on what your teacher wants. I think it would really depend on what your teacher wants you to write it as, if they want you to leave it as I cubed or negative I. So this would be equal to I cubed or negative I. Either way, I wouldn't say there's a more simpler version, but yeah, that's what that's equal to. Either one of those. So let's do one more practice problem. Or let's do a couple more things here. So we want to think about how do we simplify square roots of negative numbers, because that's kind of the main idea here. So the square root of a negative number like negative 75. Before this video, we should know how to simplify square roots. And if you don't know how to simplify square roots, pause the video and try to find another video on how to simplify square roots and go from there, okay? So remember, when we're simplifying square roots, we rewrite them with multiplication. So this we can rewrite the square root of negative 75 as the square root of negative 1 times the square root of 75. The square root of negative 1 is I, and then the square root of 75. Just a side note, write the imaginary number, write I in front of the square root, because some students will write this as the square root of 75, I. And then there's someone's going to try to say, is the I in the square root or is it outside the square root? If you write the I in front of the square root, there's no debate as to what your answer is, and you can't get the wrong answer. You write your imaginary number in front of the square root, and then there's no debate. Is it in the square root? Is it outside the square root? What's happening? But we can simplify I times the square root of 75 more. So this equals I times the square root of 25 times the square root of 3. And then after this, there's no imaginary nonsense going on with the problem. It's just regular old simplifying square roots. The square root of 25 is 5. And 5 times I is 5i. And we still have the square root of 3 there. That's the answer. Okay, we're going to do one last problem, and that's it. Let's do the square root of 30, or the square root of negative 32. I'm going to go fast for this one. This can be rewritten as the square root of negative 1 times the square root of 32. Square root of negative 1 is I, root 32. Root 32 can be rewritten as root 16 times root 2. The square root of 16 is 4, so we have 4i, and then the square root of 2 didn't go away. We still have the square root of 2. Square root of 2. 4i square root of 2. I hope you found this video helpful, and if you did, please like. And if you have any questions, please leave them in the comments below. Thank you.